Alright, in lesson 13 on Canvas, there was a little video you were supposed to watch. It showed another proof of the Pythagorean theorem, and we're just going to work through a couple of examples with that. So here we go. So across from A is 12, and across from B is 5, so we're going to plug it into the Pythagorean theorem. A squared plus B squared equals C squared. 12 squared plus 5 squared equals C squared. 144 plus 25 equals C squared. Add those together, get 169 equals C squared. C is 13. So that's A. B, okay, same thing, across from A, across from B. Now, if you notice that on here, these are similar. The only difference is that the decimal has been moved over one place to the left, okay, on our side links. So let me show you how to do that as we do this, because you should be able to do this without a calculator as well. So A squared plus B squared equals C squared. 0.5, that should be 1.2, sorry. 1.2 squared plus 0.5 squared equals C squared. This is just like 12 squared, except for you're going to move the decimal over one place. So, actually you'd move it over two places. So this would be 1.44. And you're going to move it over two places because it's squared. So you're going to move it over 2. Okay? 5 squared would be 25. But because it's squared, you're going to move the decimal over two places. Equals C squared. We're going to add those together. 1.69 equals C squared. So just like this, except for it's going to be 1.3. Okay, so that is how you can kind of see how a decimal in there changes how you play with it. We're going to do the same thing down here on number 2. 2, we get A, C, and we're solving for B. So A squared plus B squared equals C squared. A is 4, B squared, C is 5, so 16 plus B squared equals 25. We subtract on both sides. B squared equals 9. So B is 3. Okay. Down here on B, similar numbers, except for now we have decimals, so across from A is 0.4, across from C is 0.5. Okay, so B would be A squared plus B squared equals C squared. 0.4 squared plus B squared equals 0.5 squared. So we square this, 1.6 plus B squared equals 0.16. 0.25. Subtract 0.16, subtract 0.16. B squared equals 0.09. So B is 0.3. Square root the 9, so what number times itself is 9. And then because it's two numbers after the decimal, one number here, because it's, when we multiply, we move the decimal over 2. Now, when we're solving for C, this is important, I should see 1, 2, 3, 4, 5 lines. When we're solving for A or B, I should see 1, 2, 3, 4, 5, 6 lines. So make sure you guys are including that in there. Let's look at number 3 real quick. Number 3 puts two triangles inside of one large triangle. Okay, it says to determine the length of QS, so we're looking from here to here, and it gives you a hint, use the Pythagorean theorem twice. Well, if we look at this, okay, we have a right triangle on the left and a right triangle on the right. So we know that the side across from the right angles, those would be C. Okay. This would be A or B, and then we would have some length right here, and that's what we would be solving for. And then we'd solve for the left, and we'd solve for the right, and then we would put the two together to get the length of the entire side. So, what I'm going to do is I'm going to draw them separate, solve them, and then add them together. So, here we go. R, 15, right angle, T, Q, 17. So, across from there is C. I'm going to say this is A, and I'm just going to say this is the length from Q to T. Okay, you can leave it as A, or put this as A and put this as B, but I'm going to say it's the length from Q to T so that we kind of tie in what we learned from that video to this. So, A squared plus B squared equals C squared. So 15 squared plus the length from Q to T squared equals 17 squared. Okay. 15 squared is 225. Okay. $17 squared is 289. Okay, I want to get the distance from Q to T by itself, so I've got to subtract the 225. So I'm going to subtract 225 on the left and subtract it on the right. So the distance from Q to T squared equals 64. So the distance from Q to T is 8. So then up here, this would be 8 plus some number. We're going to figure that out in just a second. Okay, so now I'm going to draw my other triangle. So my right angle T, 15, R, S, and I know this is 25. So across from the right angle is C. We're going to call this A again because we called it A on the other one. And then down here we're going to call this the distance from S to T. Okay, so again, Pythagorean theorem, A squared plus B squared equals C squared. So 15 squared plus the distance from S to T squared equals 25 squared. So 225 plus the distance from S to T squared equals 625. We subtract 225 from the left and 225 from the right. So the distance from S to T squared is 400. So the distance from S to T is 20. So this would be 8 plus 20. So the length of QS equals 8 plus 20, which is 28.